Hi, I'm Greg Fung, a senior design engineer at Linear Technology. I'm here to tell you about our highly linear 50-ohm RF-IF gain block, the LTC6431-15. Communication system designers are constantly seeking to squeeze more data into limited bandwidth while reducing power, risk, and time to market. This places ever more strenuous requirements of linearity, noise, and power dissipation on the signal chain amplifiers. Linear's latest RF-IF amplifier, the LTC6431-15, has been specifically designed to address all of these issues. Let me show you the LTC6431-15 and each of these features in a bit more detail. To achieve such rigorous noise and linearity performance, RF engineers have traditionally needed to use discrete transistors to design their own amplifiers. This is an arduous task that consists of impedance matching, ensuring stability, correctly biasing the transistor while compensating for temperature, and optimizing for gain, linearity, noise, and power efficiency. With high-frequency signals, we need to consider impedance matching. We need to match the input and the output impedances of our device to 50 ohms source and load for maximum power transfer and to minimize signal reflections. To design an amplifier using discrete transistors, we typically add circuit elements to match the impedances to the source and load. These matching elements consist of inductors, capacitors, or resistors, and sometimes even transformers. Success is measured by the reflection at the input, the S11, and at the output, the S22. Next, we must make sure that the amplifier is stable and will not oscillate at any frequency where there is possible gain. Any experienced RF engineer will tell you that it's a lot easier to create an unintended oscillator rather than a stable amplifier. Typically, loss is added or the matching circuits are modified to ensure stability. These matching networks will also have an effect on the gain, noise, and linearity of the amplifier. The problem becomes a huge optimization project. Circuit simulators are a big help, but transistor models are typically lacking, and the simulators often fall short when predicting linearity. Another issue facing the RF designer is device biasing while compensating for temperature and RF power. For instance, the current of a bipolar transistor found at the core of many RF gain blocks tends to run away as the temperature increases. The LTC6431-15 takes care of all these difficulties for you. It has 15 dB of gain, is internally matched at both the input and the output, while noise and linearity have already been optimized. It's also unconditionally stable. Temperature compensation is handled internally, so you won't need a power-hungry dropping resistor that's required on many other gain blocks. All you need is a single 5-volt supply. We've also added an internal active bias circuit with voltage regulation, so the LTC6431-15 is relatively insensitive to supply voltage variations. Typically, you'd expect lower performance from a turnkey solution. However, if you consider the LTC6431-15 specifications, you'll see that this device offers world-class output IP3 of 47 dBm and very low associated noise, with a noise figure of only 3.3 dB. It does all this with only 450 milliwatts of power at 5 volts. It's tough too, sporting robust ESD protection, so with minimal effort and minimal external components, you get a highly efficient, ultralinear amplifier. Best of all, we test and guarantee output IP3 at 240 megahertz. Linearity is actually much more than just a single number in a datasheet. It's important that an amplifier maintain its linearity performance over a wide range of operating conditions, particularly RF output power and frequency. In this regard, the LTC6431-15 has some amazing specs. The left graph shows output IP3 performance over RF output power. Compared to competitive products, the LTC6431-15 offers amazing linearity over a far wider range of output power. The right graph shows output IP3 performance versus frequency. Compared to competitive products, the LTC6431-15 offers superior performance regardless of frequency, with performance good enough for IF amplifiers, ADC drivers, CATV amplifiers, or 700 to 800 megahertz LTE amplifiers. Probably the greatest focus of the LTC 6431-15 design was dynamic range. At some point, all amplifiers limit system performance. When the input signal gets too large, distortion, or when the signal gets too small, noise. Both of these characteristics have to be considered simultaneously. If we look at the input port of an amplifier, a good figure of merit would be the input IP3 minus the noise figure. The LTC 6431-15 has been carefully optimized to maximize this value, thereby maximizing dynamic range. With an input IP3 of 32 and a noise figure of 3.3, the LTC 6431-15 achieves a world-class value of 29 dB using this metric. Now let's go into the lab and see the LTC 6431-15 in operation. This is our two-tone test system to demonstrate the performance of Linear's new 50-ohm gain block. At the center of our setup, we have the 1774A-C demo board, featuring the LTC 6431-15. This demo board features 50-ohm SMA connectors for RF input and RF output. It also has connections for ground and a single 5-volt supply. We can see that the device draws only 87 milliamps. Stepping back, we see our input to the amplifier. Here we have two frequency synthesizers, one set for 240 megahertz and the other set for 241 megahertz. The signal sources are individually amplified and filtered to remove spurs and harmonics. The two tones are combined using a Magic T hybrid coupler and then fed into an RF input of the 6431-15. We monitor the amplified output using a spectrum analyzer. Here we see the spectral output, the two fundamental tones at 240 and 241 megahertz. The intermodulation products should be 1 megahertz above and below the fundamental tones. But since the LTC 6431-15 has such high output IP3, the intermodulation products are reduced below the noise floor of this high-performance spectrum analyzer. I also want to let you know that the LTC 6431-15 is only the first member of what will become a large family of products. Look for differential versions, excellent for driving ADC converters, and variants with different gains in the future. Visit us at linear.com to download an LTC 6431-15 datasheet. Thank you for watching.